Hello, welcome to today's lesson. We continue to look at the indices and logarithms, a topic as covered in Form 2 syllabus. Very essential to our Form 2s. Our Form Bs and Forms can take this lesson as a revision, and of course that will help you quite a great deal. Last time we were able to look at what indices are, and we were able to look at the laws of indices. Today we are going to look at other laws of indices that are very, very essential in handling problems related to this topic. So, other laws. Other laws of indices. Now, the first one we are going to look at is what we call the zero index. The zero index. The zero index. To understand this, consider if you are given a raised to 3 divided by a raised to 3. To work this one out, you can use our understanding of this and say a raised to 3 over a raised to 3, which is the same as a times a times a, and that is divided by a times a times a. If you simplify by cancellation, you're going to have by a1, by a1, by a1, by a1, by a1, by a1, and that will give us 1 as the answer. Alternatively, we can apply the second law of indices that we know that when we are dividing, we subtract the powers. A to the power 3 divided by a to the power 3. We subtract the powers and we have a 3 minus 3, which will give us a to the power 0. So on one hand we have 1, and on the other hand we have a to the power 0. Therefore, we conclude that a to the power 0 equals to 1. So what this one means, any number raised to power 0 is 1. Whether it is 10 to the power 0, it's 1. 1,000 to the power 0 is 1. 1,000,000 to the power 0 is 1. Should I also say that yourself to the power 0 will be equals to 1, although you are not mathematical. So, class, take note of that. Any number raised to the power 0 is 1. The second law that we're going to look at, or property, is negative indices. Negative indices. Now, consider this expression. If you have a raised to negative n times a to power n, a to power negative n times a to power n, this one will be, because we are multiplying, we add the powers, so we shall have a negative n plus n. And of course, negative n plus n, that will give us 0. That will give us 0 because the same as n minus n. So this gives us a to power 0. So we are saying that this equation, that is a raised to negative n times a to n equals to a to power 0. I want to be left with a to power negative n on one side. In other words, I want to make a to power negative n the subject of the formula. So to do that, I divide all through by a to power n. So divide this one by a to power n and divide this one by a to power n. So that will cancel, and I'll be left with a to power negative n equals to a to power 0 over a to power n. But we know that a to the power 0, any number raised to 0 is 1. So that will mean that would in essence mean that a raised to negative n will therefore be 1 over a to power n. And this is going to be very essential in handling negative indices. So what does this one mean therefore? It means if I have a raised to negative 1 is the same as 1 over a over 1. A raised to negative 1 is the same as 1 over a to power 1. Because I'm using this formula. If I have a to power negative 2 plus, that would be 1 over a to power 2. If I have a to power negative 3, that's the same as 1 over a to power 3. If I have a raised to negative 4, that would be 1 over a to power 4. In other words, a raised to negative n is the same as 1 over n, sorry, 1 over a raised to n, as you have seen in this. So therefore, if you are asked, evaluate, for instance, 2 raised to negative 3, that's the same as saying 1 over 2 raised to 3, which will give us 1 over 8. So that's very, very key about negative indices. We are going to look at fractional indices. Fractional indices is now our third. As you can see, fractional is from the word fraction. We are talking about indices that are fractions in nature. And when we talk about a fraction, you're saying they can be expressed in the form p over q, where p and q are integers and q is not equal to 0. So these are fractional indices. They can be expressed in the form of p over q, where p and q are integers. Integers are basically whole numbers, and q is not equal to 0. Is not equal to 0. So those are fractional indices. And then consider this. If you are given a raised to a half is a fraction. This would mean introducing a root sign of a, and the root of that number is the 2 that we have here, which is the square root. So a raised to a half means the square root of a. If you have a raised to a third, it will mean the root sign of a, and this is the root of that sign, that is 3. That would be the cube root of a. If you have a raised to a quarter, that would be the 4th root of a. And therefore, if you have a raised to 1 over n, that would mean the nth root of a. We're going to look at this, maybe 1 or 2 examples of this, so that you can understand this more. Examples. You are told to evaluate